So, 7th grade, here we go. This image that I'm showing you right now, this image, I took a picture of it. I posted it in Google Classroom. This might be something you want to get and maybe copy down or print off or at least open up on your computer or phone or whatever. But that's there. I'm not going to focus on this. It is posted in Google Classroom, also under materials with this video. So they're both going to be there, but I do want to just read through this. Today we're focusing on classifying triangles. You know what a triangle is. I don't have to explain that. It's a closed three-sided polygon. We can classify triangles by their sides. We have equilateral triangles where all sides are the same length. We have isosceles triangles where at least two sides are the same length. It could be that two sides are the same and one is different, but technically an equilateral triangle where all three are the same is also considered an isosceles triangle because two of the sides are the same. In a scalene triangle, all sides are different lengths. We can also classify triangles by their angles. An acute triangle means all of the angles are acute, which means they're less than 90 degrees. A right triangle has one right angle, meaning one of the angles is a 90-degree angle. An obtuse triangle has one obtuse angle, meaning one of the angles is greater than 90 degrees. And then we have equiangular, that's a tongue twister, equiangular triangles where all three angles are congruent. Triangles have three sides and they have three angles. So this assumes that you understand that a triangle has 180 degrees. If you don't know that, 7th grade, now you do. All three angles in every triangle you will ever see, if it truly is a triangle, the sum of all three angles added together will always be 180 degrees. This is something that you're going to want to know. Okay, all angles are 100. All angles added up in a triangle are 180 degrees. So, knowing that, I'm going to zoom away from this, and we're going to actually talk about what's happening on your assignment. So I'm going to push that out of the way, get my other handy-dandy whiteboard here, and here we go. So, part of your assignment is going to give you a triangle. And it's going to give you something that looks like this. Okay, it's going to say, okay, here we go, and here we go. And it's going to say, it's going to have something like that. It's going to say that this angle right here is 40 degrees. It's going to say that this angle right here is 40 degrees. And it's going to say that this angle right here is 100 degrees. Now, first of all, we can add all those three numbers together. 40 plus 40 is 80, plus 100 is 180. Thus, we have a triangle because it equals 180 degrees. So I want to think, well, first of all, this is not equilateral because all sides are not the same length. I don't have to measure them. These two indicators here tell me that those two sides are the same. If they're marked like that, whatever one they're marked similar with like that, it means they're the same. So those two are the same. And the rule for triangles is if I'm going to have two angles that are the same, then I'm going to have two sides that are the same. So because it has two sides that are congruent, I would classify this as isosceles. Okay? So that would be an isosceles. It is not scalene because all sides are not different lengths. It has two sides that are the same. It is not equilateral because all three sides are not the same. And so it's just isosceles. Now if I want to classify it by angles, it is not an acute triangle because all the angles are not acute. I have one of the angles here that is bigger than 90 degrees, and acute angles mean they're all less than 90 degrees. So this is not an acute triangle. It is not a right triangle because it does not have one right angle. Remember, a right angle is 90 degrees. So there is not a 90-degree angle in this triangle, so it is not a right triangle. It is an obtuse triangle, however, because an obtuse triangle, remember, has one obtuse angle. An obtuse angle means greater than 90 degrees. Now, we talked yesterday about the straight angles. We're not worried about those today. Obtuse, for what we're talking about today, greater than 90 degrees. We have a 100-degree angle here, so this is definitely an obtuse triangle. This is not an equiangular triangle because in an equiangular triangle, all angles are congruent. And we have two that are 40 and one that is 100. They are not all congruent. The next part of your assignment tells you to do something different. Okay? And we're going to look at one here. I'm going to draw a triangle here. Ignore my camera work for a second. Okay. All right, and we're going to look at something like that. It's going to say, okay, that this one right here is 22 degrees. This one right here, we're going to say that's 31 degrees. And this is going to be x degrees. And the directions are going to tell you to, first of all, find the value of x and then do the same thing we did over here. You have to classify the triangle in as many ways as possible. All of these words over here, when you're classifying the triangle, you need to include any and all of those that classify the triangle. If you're missing any, it's incorrect. If you have extra ones, incorrect. So you want to be very exact and look through these in all of them. We'll talk more when we do it actually together in Zoom, but you're going to get the idea. So first of all, you'll remember what I said. I want you to answer the question. Actually say it out loud. See if you remember from a few minutes ago. How many degrees are in a triangle? Very good. I heard all of you say 180. 180 degrees. All three angles in a triangle work out to be 180 degrees. Now, I don't have my calculator with me. You do have a calculator. But essentially what you should do is take 31 plus 22, which are the two angles that you know. Okay, 1 plus 2 is 3. 3 plus 2 is 5. So that's 53. And since I know the total is 180, to actually solve for x, I will then take 180 and I will subtract 53. I can't do 0 minus 3. I borrow from the 8, make that a 7. 10 minus 3 is 7. 7 minus 5 is 2. 1 minus nothing is 1. And it's 127. I now see that x equals 127 degrees. Now that I know the angle measurements, I need to make a determination now to classify the triangle. Well, first of all, by sides. Okay? All sides are not the same, so it is not equilateral. Okay? How do I know if the sides are the same? Some of you may be thinking, well, Mr. Swack, you're not even measuring the sides. Well, I know by the angles. If all three angles are different, then I know that all three sides are different lengths. Okay? If the angles are different, the sides are different. So clearly in this one, since the angles are all different, the sides are not all the same, so it cannot be equilateral. Here in this, I do not have two angles that are the same, thus I don't have two sides that are the same. So it is not isosceles. This would be scalene. Since all the angles are different, all the sides are different. Thus, that qualifies this triangle as a scalene when I am classifying it by sides. Now, when I classify it by angles, I see that I have a 127 degree angle. That is bigger than 90 degrees. So that is not an acute angle. For it to be an acute triangle, all angles have to be acute. All three angles have to be acute. Okay, so this is not an acute triangle. It is not a right triangle. A right triangle would have a right angle that would be 90 degrees. Okay, and so it is not a right triangle. This would be an obtuse triangle, however, because one of the angles, the one we figured out for x, is 127. That's bigger than 90. Thus, it is obtuse. When I classify this triangle by its angles, it would be obtuse because it has one obtuse angle. It is not equiangular. If it was equiangular, all three angles would be the same. And so it is not equiangular. So when I solve for x, that's 127. When I have scalene and obtuse, those are its classifications by sides and angles. The last part of what you're doing is going to do this. It's going to give you three angle measurements. Okay? So it's going to say, okay, 76.2 degrees, 81.7 degrees, 22.1 degrees. And it's going to ask you, can a triangle be formed with these three angle measurements? So I asked the question, well, how in the world can we know whether or not a triangle can be formed from these three angle measurements? Well, it's that key piece of information that I shared with you before. And I'll ask you again. The sum of all three angle measurements in a triangle is what? Scream it through the screen. Ah, I heard you. Very good. 180 degrees. If all three of these angles added together equal 180 degrees, then those three angles can form a triangle. So all I have to do is plug these three numbers into my calculator. I'm not even going to use a calculator. You're allowed to use a calculator. I'm not going to. But all you have to do is add those three numbers together, okay, and see if it equals 180. So here we go. 2 plus 7 is 9, plus 1 is 10. So I'm going to put the 0 down, carry the 1, drop my decimal. 1 plus 6 is 7, plus 1 is 8. Add the 2. That gives me 10. I'm going to put the 0 down, carry the 1. 1 plus 7 is 8, plus 8 is 16, plus 2 is 18. And voila, 180.0. This is definitely a yes, because it can form a triangle. Now, if I go to number 2, let's look at another example. 115.1 degrees, 47.5 degrees, and 93 degrees. It's important to remember, keep your decimals lined up. There's no decimal in 93. So as a 7th grader, you should know, oh, well, that has to come over here. And if you like it better, if you're going to do it on paper and scratch paper, do 93.0. Now, so once again, I need to see whether or not this forms a triangle. And I'm going to do the same thing. I'm going to add them all together to see if it equals 180. Now, right away, you're probably going to realize, well, 1 plus 5 plus 0 equals 6. So common logic tells us, well, 0.6, if that's what it ends with, it's not going to equal 180. Well, we wish it could be that easy, okay? Clearly, this is going to be a no. However, the directions ask you to do one additional thing. They ask you, if it is a no, how does the first angle need to change? How does the first angle need to change? So, I clearly see that this is going to be a no. It's not going to equal 180. So it's like, okay, this is the first angle. That's the one that needs to change. Okay? So the ones that are going to stay the same are 93 and 47.5. So what I can do is I can erase this 6 out of here. Pretend that we never did that. I'm going to erase my 115.1 out of there. And I'm going to add the 2 that I know that are going to be part of it. Okay? So 5 plus 0 is 5. 7 plus, drop my decimal down. 7 plus 3 is 10. Put the 0 down, carry the 1. 1 plus 4 is 5. Plus 9 is 14. 140.5. But then it says, how does the first one need to change? Well, all I have to do is figure out what the first angle would then need to be. So we go back to our original question. How many degrees are in a triangle? Well, that's 180. So to figure out what the third angle is going to be, I simply have to take 180 and I'm going to subtract 140.5. Keeping my decimals lined up, okay, and doing all of that stuff. I'm going to add a decimal 0, okay, and so I'm going to look at my subtraction. 8, 7, that becomes a 10, becomes a 9, that becomes a 10. 10 minus 5 is 5. 9 minus 0 is 9. 7 minus 4 is 3. I get 39.5 degrees. And so my answer in that section needs to be no, it would not be a triangle. But to be a triangle, the first angle would have had to be 39.5 degrees. We'll talk more during class time. I'll talk to you later, 7th grade.